Okay, everyone. Welcome to the second video in a series of videos about the Newsvendor model. In the previous video, I talked about the basics of the Newsvendor model, the idea of cost of understocking, the unit cost of understocking, the unit cost of overstocking, and we went over some of the formulas there. So, I showed you some of the formulas there. So what we'll do now is we'll implement that basic thing. So here's the example of where the mean is 350, standard deviation is 100. Sales price is 250, cost is 100, and this disposal value is 85 with a holding cost of 5, right? So let's include all of this to calculate the values that we have. So I put some, I basically set the Excel sheet up, and this is a standard way of setting it up in this case. So mean was 300, the standard deviation of 100, wait, 150, right? Already forgot. 100, no, it was 100. Okay. Right, the sales price was 250. The cost was $100, and the salvage value was, well, it was $85 is how much you can get back after the season, but there's also a cost of holding it for the whole season of $5. So essentially you can only get back $80 of salvage value. And this is a very common way with salvage value, is that you will have a cost that you can claw back, and then you'll also have to pay some cost for holding it for the season. So just keep that in mind. And I don't think it's cost of overstocking, but yeah, there you go. Now, what is the unit cost of understocking? So the unit cost of understocking is the cost of having one fewer item, which is the difference between the sales price and the cost. So this is how much money you lose by not having enough. So for every unit that you don't have enough, you lose $150. That's how much money you lose. Now, the unit cost of overstocking, so this is when you have extra, it's the difference between the cost and the salvage value, right? Okay, so if you overstock, so if you have too many items, it's going to cost you about $20. If you have too few items, it is essentially going to cost you $150. So as you can see here, there's a mismatch. The cost of overstocking is way less than the cost of understocking, right? So it is way better for us to overstock than to understock. Keep that in mind. So the cycle service level is calculated as the cost of understocking divided by the sum of the cost of understocking and overstocking, right? And that will turn out to be 0.8823. I'm just gonna bring it down to 4 decimal places, 0.8824. That's your cycle service level, or 88.24% is your service level, which means that anytime during the season, if somebody shows up, there's 88.24% probability that they will be able to find something available for them to buy from, right? Now, using this, we can calculate the optimal order quantity. So we are assuming that the demand follows a normal distribution. We know the mean, we know the standard deviation, and we also know the cycle service level. So with that, we can calculate the optimal order quantity as norm.inv, so the inverse of the normal distribution, using the cycle service level as a probability value. The mean is, well, the mean, and the standard deviation is the standard deviation, as you can see, right? Okay, give me a second. Okay, good. Now, with this, so the optimal order quantity turns out, so this is not a whole number. So what I like to do is I always like to round this up. So round it off to the closest value. So when you use the round formula, so this is the normal inverse formula. You are rounding it to 0 decimal places. That's the comma 0 that you have. It's 0 decimal places right there, right? So 419 is the optimal order quantity. So with that, I can now calculate the expected profit, expected overstock and understock. But for that, I'll have to look at the formula, because the formula is pretty involved. So let's do that again, right? So let me move that over there. So let's begin with the cost of, let's do the expected profit first, right? Right, so that's the expected profit. Right, so the expected profit will be, so I'm going to write out the whole expression, and as you can see, it is definitely pretty involved. So it's P minus S, right? So it's P minus S, P minus S. It's the difference between the price and salvage value times the mean times, when you have the capital F there, that's norm dot S dot, you see the S at the bottom, which means it's a standard normal distribution, right? Not the general normal distribution, but the standard normal distribution. So we'll say norm dot S dot dist, right? Oops, I think, yeah, that's just right there. It's norm dot S dot dist, standard normal distribution. Now they use the 0 and the 1 here for the mean and standard deviation. You don't have to do that. I mean, if you use standard normal distribution, the mean and standard deviation come up automatically, so that's fine. So it's O minus mu over sigma, so it's going to be the optimal order quantity minus the mean divided by the standard deviation, right? O minus mu over sigma, and then comma, then it says cumulative. Cumulative is true or false, so you can either type in true because you see this 1, or you can just type in 1. 1 just means it's true, right? So we are using the cumulative distribution, and that's just the first part of the formula. Now let's write the second part of the formula. Maybe I'll just make this slightly a little bit more. Okay, so that's the first part of the formula. Let's say minus. Now it says P minus S. So P minus S again. Oops, sorry. P S, right? Times the standard deviation now, times, this time it's not the, it's a normal distribution, but it is not the cumulative one. So, but it's still the standard normal distribution. So we'll do norm dot S dot dist, standard normal distribution of O minus mu divided by sigma. I know this is involved, so please forgive me. Divided by sigma, O minus mu divided by sigma, and this time it's comma 0 because we are not using the standard normal distribution. We are not using the cumulative distribution. We're just using the basic probability distribution. So that was the second half of the formula, second part. Now let's do the third part. Minus the optimal order quantity times C minus S, C minus S, right, times normal distribution. So this time it's not a standard normal distribution, it's basic normal distribution, and we are using cumulative here, so it's norm dot dist, right? So norm dot dist of the optimal order quantity comma mu comma standard deviation, right, comma 1, right? So that's this part of the formula. Finally, plus optimal order quantity times P minus C, so that's price minus C, right, times 1 minus norm dot dist of the optimal order quantity mean standard deviation comma 1 because it is cumulative, right? And then we close the parenthesis for the 1 minus, and there's that, right? And that's the formula for the expected profit. So I got 41,646. So let's see if it turned out to be the right 0.88. So they truncated it at 0.88, and that's why they got 468. That's fine. Oh, it's 350, not 300. I'm sorry. Right. Okay. And they got 49,146, 49,146, right? So even though mine was slightly off. So they had 468, I had 469, but the numbers basically turned out to be the same. So the reason I'm checking is to make sure that my formula that I typed in was correct, and it looks like it is correct. Okay. So that's the formula for the optimal expected profit. Now, as you can see, there's a reason why I did this. As you can see, it took me a while to type this in, right? So I'm going to post this Excel sheet. Make sure that you make copies of it. That way you don't have to type the formula yourself. You're just calculating the formula and interpreting the results rather than spending time typing in the formula yourself. All right. Okay, now let's do the formulas for the expected overstock and expected understock also. So let's quickly do expected overstock. So the expected overstock is O minus mu, optimal order quantity, minus the mean, right? Times 1 minus, times norm dot dist. No, that's the standard normal distribution. So norm dot s dot dist, right? So standard normal distribution of O minus mu over sigma, right? And this is cumulative, comma 1, right? So that's the standard normal distribution part for the first part. And the second one is just standard deviation times, this time it is still norm dot s dot dist, the standard normal distribution, but O minus mu over sigma, but this time it is not a cumulative distribution, it's just the probability distribution, right? So that's the second half of the expected overstock. There you go. Now this I'll fix that in a second, and then we can do the expected understock, right? So the expected understock will be mu minus O. Oh, oops. Times 1 minus norm dot s dot dist of O minus mu over sigma first for the cumulative distribution, right? So it's 1 minus norm dot dist plus the second part is the same, as you can see, right? The second part is the same, plus standard deviation times norm dot s dot dist of O minus mu over sigma, right, comma 0. This time it's not the cumulative distribution, right? There you go. Okay. One is O minus mu, the other is mu minus O. So the formulas are in. I think we're done here. So I'm just going to move that over. So a couple of things. I just want to get these down to 0 decimals. I'm not going to round them up. I'm just going to get rid of the decimals. So the expected overstock is about 125 items and the expected understock is 6 items. Expected profit, that's a dollar value. Let's do that. These are all dollar values, right? Let's give them dollar values. We don't want any decimals though. So there's that, right? Okay, so this is cycle service level. I like to show it as a percentage, so I'm just going to show it as a percentage, 88.24%. And that's the expected overstock and expected understock. So we can calculate the total cost of overstocking as the unit cost. So cost of understocking will be the unit cost of understocking times the number of units that you expect to understock by. And then cost of overstocking times the number of units that you overstock, right? Overstocking. This is understocking. I don't know why I switched these. It's bugging me now. You know what? Let me just fix that. It really doesn't matter, but you know, it's gonna bug me. So understocking is understocking and overstocking is overstocking. Okay, good. Right. Now, what this tells you is that because the unit cost of overstocking is just $20, it is more likely that you'll overstock. So the expected overstock here is 125. And if you did end up with understock, so why is it that you'd end up with an understock? Even if the cost of understocking is 20 and you are ordering so many items, it's because demand is random. We are assuming that it has a mean of 350, standard deviation of 100, it's a normal distribution. But what if demand was just say 200 or something, right? So demand can be on the low side. So averaging out all possibilities of demand and everything, you say that on an average, if you end up with an understock, it'll be about 6 units. And if you end up with an overstock, it'll be about 125 units. And that's okay because the cost of overstocking is only $20, while the cost of understocking is $150 per unit, right? So the total expected profit that we have in this case is $49,146.53. And that is the Newsvendor model. So in the previous video, we saw the theory behind the Newsvendor model. In this case, we saw how we can set it up in Excel and calculate the probability, calculate the values themselves. Now, once you have this template set up for different scenarios, you can calculate the overstocking, understocking, and all of that, and you can figure out exactly what's going on, right? So this is the Newsvendor model. Now, there are multiple examples of that in the textbook. End of chapter problems, I suggest that you do a few of these so you're comfortable using them. What I will do in the next video is we'll talk about some extensions of the Newsvendor model, right? I'll see you in the next video. Take care.